So what I want to talk about today is how you as a developer can transition to data science. And maybe a little disclaimer before I start is I am not a freelancer. I did a bit of freelancing like 5 years ago. I think it is completely different, a different world right now from what it used to be like 5-6 years ago. But I know that you are software engineers, and maybe you'll be wondering about this new world, or it's not super new, but like it's still kind of hot, it's popular, this machine learning, data science. You probably see some projects that popping up in what are these places? How are they called? That, exchange or like project exchange. Maybe clients say, yeah, we want to add machine learning to our projects. Can you help with that? So what I want to show you is maybe actually a good idea if I start sharing my screen. So let me do that. I think I want to share this thing. So sorry, a bit of spoiler. So what I want to talk about today is I want to talk about how you as a software engineer can transition to machine learning. So let's start. So the main message I have today, so if there is anything you want to take away from this presentation today, is that you as an engineer, you are already qualified to do machine learning. So let me move it a little bit because I don't see. Yeah, okay, that's better. Like I had this window with faces that was covering like my whole slides. So this is the main message. And before we start, I want to add a few words about myself. So I actually started my career as a software engineer. It was quite a while ago, so 2010. So this is when I graduated from my university and I got my first full-time job as a Java developer. So I worked as a Java developer for a couple of years. And then after a few years, I ended up in a bank. And around that time, a course from Stanford, from Coursera appeared. It was called Machine Learning. So I watched that course, and this is when I understood that, I need to do that. I need to get into machine learning because it's so exciting. And basically, this is what I did. So I did a master's. And then a couple of years after that, I started working on my first full-time job as a data scientist. It was at Searchmetrics. So it was in Berlin. So I've been living in Berlin since 2014, I think, so for quite some time. So I studied in Berlin at the Technical University. So then I worked for a couple of years at Searchmetrics. Then I joined a startup. In a startup, I needed to build a lot of things from scratch. Actually, my experience as a software engineer was very useful in all these years. So when I worked at Searchmetrics, they had a system like the production system was written in Java. So my background in Java was very useful. Then at Simplex, we were a small startup and we needed to do a lot of stuff from scratch. And again, my engineering experience was super useful. And now at 2LX Group, I lead a small team. And our job is to help other data scientists with productionizing machine learning. So I'll talk a little bit about that. But looking back at my career journey, so when I decided to transition from software engineering to data science, I think I did a big mistake. This mistake costed me 2 years. And this mistake was a master's degree. So I don't think if you want to transition now to software engineering, from software engineering to machine learning, I don't think you need to do the same mistake. You don't need to spend 2 years getting masters because, and you will know now from this presentation because there is a faster way of doing this. So what I'll show you today is actually I wrote a book called Machine Learning Bookcamp. So this is an introduction to machine learning for software engineers. And what I'll tell you in this talk is based on that book. Of course, you don't have to have a book, but if you want, so this is based on the book. And so in this book, I try to put all my experience as a software engineer, and I am talking about things that work best. And here I'll give you a gist. So, and actually this works for software engineers. So multiple people told me, hey, this is a really great way of doing these things for sharing me. So I'll start with a picture of a system that we have at OLX. So you don't need to understand what's going on in this picture. What is important here is there are a lot of things here. So this is a content moderation system. So this system uses machine learning to understand if, so maybe I'll give you a bit of context. So OLX is an online marketplace. So this is a place where you can go if you want to sell your phone, for example. So you have a phone, you want to sell it, you go to OLX, you upload a picture of your phone, and then somebody who is interested in buying your phone can contact you and then basically buy it. So we have a system to detect unwanted content. So let's say somebody wants to upload a pornographic image, or somebody wants to sell a gun, or somebody wants to sell some drugs. So this is not allowed, of course, and we have a system for detecting that. And we use machine learning for that. So this tiny bit, I hope my you can see my mouse here. So this tiny bit here, I can zoom in a little bit. So this tiny bit here is machine learning. But the rest of the system, like everything else around this, like creating this moderation panel, like, all these things like fetching the image if you're detecting a duplicate, like computing all these things, this is all engineering work. So machine learning is only a tiny bit of that. And the rest of the system is basically connecting cables. So you have multiple things, and then you need to somehow integrate them so they work together. So let's say you need to take this machine learning and integrate it into existing system. And this is what you as engineers, you really know how to do this. So usually this is a pretty typical machine learning project. You have a bit of machine learning and the rest is engineering. And then this fact is acknowledged by many companies. There is a paper from Google. It's called Hidden Technical Debt in Machine Learning Systems. And they show that the code for doing machine learning is only a small fraction of the entire system. And then to make it work, to make this little piece work, you need to have a lot of things around that. So this is again mostly engineering work. And what I wanted to say you with all these things is that you as an engineer, you already have 90% of the required skills to do machine learning, because you know how to do all these things around this. So you already know how to, I don't know, use AWS, for example, or use a web framework to design a moderation panel, all that. Like you already know how to do this. What you don't know probably yet is how this thing might work. But the good news is this is only 10% of the work, but the remaining 90%, you already have this. So you just need to find a way, how do you feel it, how do you acquire this 10%? And then you can work as a data scientist or as a machine learning engineer and use machine learning at your work. So let me tell you how you can actually do that. So you need to come up with a learning plan. So in this plan, you start with fundamentals. And fundamentals here, I will tell you what it is. So it's not, getting a PhD in mathematics. So it's a bit simpler. And then you start with learning simple algorithms. And here learning is more like learning how to use them, not learning how to implement them from scratch or learning how to derive mathematical formulas from scratch. It's about taking existing implementations and using them. And then the important thing is, so now if you learn how to use them, you need to evaluate how good your model is. So you need to learn that. And then once you have that, once you trained your model, once you evaluated your model, you need to deploy your model. And by deploying, usually what people mean when they say deploying a model, it's taking your model and putting it inside a web service. You as software engineers, you already know how to do this. So for you, it's not really a new thing. Maybe you just need to learn I don't know, in Python how to do this, because in data science and machine learning, we usually use Python. If you're experienced with Java, then you will need to spend a little bit of time seeing how you can use a framework that is similar to what you have in Java, just in the Python world. And then when you know that, you're already 80% there. So you just need to learn a little bit more complex algorithms. So let me go into details of that. And yeah, of course, the important thing is, if you want to learn this, you don't need to, open a textbook and start reading through this textbook, then picking up the second textbook, third textbook, until you read all the textbooks in Amazon, right? So the way you learn it, the way you approach it, is by doing projects. So you pick a project and you walk through this project and then you pick another project, and then you have a third project, and then you have a project portfolio, and then you use this project portfolio to convince your clients, let's say, if we're talking about freelance, that, hey, I already know how to do machine learning. Let me show you that. And that this is how you should think about this. So learning by doing project is the best way of learning this thing. So I promise you to talk about fundamentals, and these fundamentals is not the mathematical skills. The fundamentals are, again, it's engineering, it's the libraries in this data science ecosystem that pretty much everything relies on these libraries and on these things. So first of all, Python. So this is the language of machine learning. So right now, of course, there are other languages, but you have to know Python if you want to get into machine learning, because most of the libraries are written in Python. The community uses Python as the default language, so you have to know Python. Luckily, the syntax is super simple. So if you know how to program, for you, learning Python would take, I don't know, 10, 15 minutes, not more. Then the next thing is NumPy. So NumPy is a library for doing numerical manipulations. So this is, it's just an effective way of processing numbers. And then pandas, you can think of pandas as sort of Excel spreadsheet. So you have a table. So the main data structure there is a data frame. So you can think about this as an Excel table, and you can, or maybe not an Excel table, because you can also do group by there and things like this. So these three things are probably the most important things that you need to know if you are serious about data science and machine learning. And luckily, they are not that difficult. And you can just go to your favorite search engine and write, learn NumPy in 20 minutes, and then you will have thousands of tutorials. And then that is sufficient. You don't need more than that. So you learn that, and then I want to show you something scary. So this is something that I guarantee that every software engineer is afraid of. And I think this fear comes from university, because the way we are taught at universities is maybe not ideal. So I don't know how many of you know what I'm going to show you, but this is a mathematical formula. So this is the scariest thing that software engineers can see when they transition to machine learning. And I remember myself, the moment I see a formula, my mind just goes blank. Like, okay, this is just too complex for me. There is no way I can understand what's going on here. So I'll just give up. I will not try to learn machine learning, because I know there will be a lot of formulas. It's mathematics, and I was bad at mathematics at school, so I better not do this. So you shouldn't be afraid of that, because actually, this is just a different perspective on things. So you just look at things differently. So mathematics, you can think of this as a coding language, as a programming language, right? So here, this is an expression from linear algebra. So you have a few matrices, you multiply these matrices, and all these operations can be expressed in code. So you can take some time, a couple of hours of your time, and try to write some code for doing matrix multiplication in Python, for example. And then this should be sufficient to convince yourself that this formula is actually not scary. So you can translate this formula to code. And once it's translated to code, it's no longer scary, because you understand what's going on there. So I really advise you to take some time and try to actually, I have a next slide about that. So you need to convince yourself that all these things you see in math is nothing else but a bunch of for loops. And you as developers, you already know how to deal with these for loops. So I bet every day you write like 10, 20, 30 for loops. So for you, implementing this matrix multiplication in terms of for loops shouldn't be problematic. And once you see that this is just for loops, then it becomes less scary. And this is the approach I took myself when I was transitioning, is I was trying to break down these formulas into code. And once I have them in code, then they are not scary anymore. So you can try to implement, let's say you have two vectors and you need to write some code for multiplying them. Then you have a matrix and you have a vector, you want to write some code for multiplying them. And then finally, you want to take a matrix and another matrix and write some code for multiplying them. Of course, we don't usually write code for that because there are libraries, like I mentioned, NumPy, that you just take one matrix, you just take another matrix, and then you write multiply. That's all you need to do. But it just helps you to overcome this fear of mathematics. At least this is what helped me. And then I promised you that I told you already that the best way of learning is learning by doing projects. So of course, these fundamentals, you need to pick them. And as I said, you can just find a tutorial and walk through this tutorial. And then you will probably come across math. This is not scary. But then how do you actually go about learning machine learning? So as I said, you learn by doing projects. And now I want to show you a couple of projects that you can do in order to pick the skills you need. And here the skills, so I want to focus on this, Pareto rule. So what are the 20% that will give you 80% of the return? Right. So the projects here that I am going to show that will give you this. So they will not take a lot of time, but they will give you, this 80% of return. So the first project that you can build is you can build a system for predicting the price of a car. So let's say you have a bunch of cars. So this is actually a picture from OLX. This is the company where I work. So there we have a section of cars. All the cars have prices. So what you can do is you can build a system. You can build a model that looks at different characteristics of a car. So it can look at model, it can look at make, it can look at mileage, age of a car, all these things. You know that these things, they, let's say if a car is young, if it's not old, then it's more expensive than a car that is old. Right? So you can take all these things in consideration and build a system, build a model that takes all these characteristics of a car, and then you can use this for predicting the price of a car. So I highly encourage you, to actually try to figure out how to do this yourself just by Googling things. I think we as software engineers are pretty good at Googling things or whatever search engine you use. Maybe Bing, I don't know. But yeah, so we're good at finding information. So of course you can just find a tutorial and go through this tutorial, but it's much more fun and it's better to learn this way if you come up with a problem. So the problem is, okay, I want to build a system that predicts the price of a car. And then you start looking for information, how do you actually do this? And then you will find different articles, different tutorials, and then you kind of combine them all together. And then you know how to do this. So of course I give you a link so you can, so this is, and like this is code from the book that I mentioned at the beginning. That's actually one of the projects from the book. And this is a project you can do. And if you do this project, you will learn about regression. So regression, this is a concept from machine learning when we want to predict a number. So here, the price is a number. So we need to build a linear regression model for predicting the price of a car. So you can do this as a first project. And then the second project is, so the previous project I talked about was predicting a number, so the price of a car. The second project is about classification. So imagine that you're working at a telecom company. So telecom company sells things like internet. I guess that's mostly what they sell. So internet, mobile, like all this, basically ways of communicating. So they have a base of clients, a base of customers. And then some of these customers, they are thinking, there is this new telecom company that seemed to give better, like cheaper prices, better services. Let me try that company. So what these clients do, they terminate, they contract with us and go to a different company, right? So this process is called churning. So they decide to end their contract and move on to find a different internet provider. So the project I suggest you to do is to take a data set with a similar data set with a customer base and then predict which of these customers are going to leave our company soon, are going to go to our competitors and have a contract with them. So in this particular case, we're talking about a telecom company. So we're looking at things like how many months the customers spend with us, what type of contract they have, and things like that. And this is a classification problem. So we want to predict if a person is going to leave or not. So this is called the binary classification problem. So 1 means a customer is going to leave, 0 means they're going to stay. And then the model would predict a probability that a person is going to churn. And we can use that for understanding who we need to try to convince to stay with us. So this is a great project. And what you can do this as the next step is take this project and understand how you can evaluate the quality of this project, of your model. This is a very important thing. This is quite difficult. I think this could be the most difficult thing for you as a software engineer, because this appears a little bit abstract. But here you measure things like accuracy, how accurate my model is, like is it good or not, and things like this. So there are the metrics that are called, metric is a way of evaluating your model, metrics that are called like precision, recall, AUC, all these things. So you need to understand how they work and you need to be comfortable using that. And I think this is the most difficult part for you. It was for me because it's a little bit abstract and just needs practice. And if you do, let's say 3 projects, then I'm sure you will be able to get these things and use them. So this is something you have to do this. You have to do, this is important. And then there's another important area, which is deployment. It's as important as evaluating, because let's say you trained a perfect model, but if you don't expose this model, if others cannot use this model, your model is basically, you can just consider it useless and you can just throw it away, because if nobody can use it, then your model is not bringing any value to the company, right? This is probably the most important step, is once you train a model, is making it available for others to use. The good news here is that for you as a software engineer, you already know how to create web services. You already know how to like deal with all this stuff. You already know what HTTP is, what REST is, and all these things. So you just need to give it a little twist and now know that inside the service you have a model, right? And that's the main difference. So you're again getting a JSON in request, and then you're getting JSON back. Just inside what this service is doing, it's applying the model. And then this is an important step. You have to learn this. The good news is easy for you. And yeah, so that's this is what you can do. And then let's talk about the third project, because I'm not sure how much time actually I have. Do I have time? Yeah.
5 minutes, yeah. 5
minutes. Okay, let me just try to rush it. So the next project you can do is, let's imagine that you are working at a bank, and then somebody comes to you and says, hey, I want to buy a car, give me some money. And then the bank needs to assess if this customer, if you are going to give back the money, if you're going to return the money or not. So banks usually have a credit risk system for determining if you're going to default or not. And default means you will not be able to pay back the loan. And then the bank uses this model to understand if they should approve your request or they should decline. So you can build a model like that. And again, here we have like a binary classification case. So we either approve or not approve. So yeah, and you can use, so for example, in this, oops, I'm going the wrong way. So in this churn model, so you can actually learn logistic regression. This is a type of model for doing binary classification. And in this credit risk project, you can learn a different type of model. So it's called tree-based models, decision tree, random forest, and all these things. Of course, there are some resources that you can check, but try to learn a different type of algorithm here. And then, of course, use the things you learned previously, like how to evaluate the model, how to deploy the model, and then learn a new family of algorithms. Then I think this also could be important. This is something that is getting more and more traction, is doing machine learning on images. Like let's say, so in this example, the project I propose to do is, imagine that you're working at a company like OLX, and then you have this fashion category, basically clothes. And then we want to help our customers with detecting the category. So let's say I want to sell a t-shirt. I take a picture of a t-shirt, upload it to the website, and then the website says, hey, it's a t-shirt. So this is a simple image classification. So we want to classify an image of clothes into 10 categories. And then for that, you need to use a neural network. So before we used the simpler model, but here you can you should use a neural network for images, right? And I think this is getting more and more popular, like these image-based models. So this is something you should also consider adding to your portfolio. You don't have to, but if you're into this kind of stuff, into images, and I think they are also cool and useful. So it wouldn't hurt learning about neural networks. And then you can use frameworks like Keras and TensorFlow for doing that. And again, the way I would approach it is just by doing a lot of Googling and then figuring out how to put all these pieces together. And then what you can do is, I didn't mention that, but there are multiple ways of deploying your model. So you can deploy it with, for example, AWS Lambda. I think this is becoming quite popular. And you can deploy it with Kubernetes. So Kubernetes probably uses as software engineers, you already know Kubernetes, and you'll just need to think, okay, like I already know how to use Kubernetes, but how do I use Kubernetes for deploying machine learning models? You can spend some time doing that. Of course, I have all the materials, so you can check that. But as I said, it's far more fun to actually figure out this yourself instead of following a tutorial. So you can do this for projects. Again, maybe let me summarize. The first project is predicting the price of a car. The second project is predicting if a customer is going to churn or not. Then credit risk scoring project. And then the fourth project is classifying the types, the images of clothes. So let's say you build all these projects. You have 4 projects in your portfolio now. What you can do next is you can learn more, go to Kaggle and take part in data science competitions. Also, Top Coder, I think, is hosting data science competitions. You can do that. And then try to think about an end-to-end project that is your own and do that. So that should be very helpful. And then the last thing is you don't have to do this alone. So there are communities out there. There are people who are also learning like you. So you don't have to just sit in front of your computer and trying to bang your head against the wall, trying to figure out why something is not working. You can just join a community and learn with somebody. And the reason I'm telling you is because I happen to run a community, DataTalksClub, which is a place where data professionals and data enthusiasts can talk to each other. So you can, if you need some help with machine learning, with learning machine learning, or with using other things like data analytics, data engineering, you can join this community and ask for help or help others. So do that. That's an amazing place. And that's just datatalks.club. Put this in your browser and you'll find there is a form for registering. And then finally, I'm also running a free course based on the book. So the course is completely free. And what we're doing in the course is we're going through all these projects that I described. And there is a bunch of videos that I recorded. And you can just follow through these videos, do that. And then the important thing there is there are projects and there are homeworks that you have to do on your own without following the tutorial. And this is that you have to do. This is where you really learn. So if you're interested, the link is mlzoomcamp.com. So you can check it out. So let's jump directly to questions. Yeah, this is how you can find me, but I'm happy to take questions.